Hello, guys. I'm so happy to present this lecture. So, I hope we shall start. Okay, we shall start. Okay, by the way, so in last class, I have given a brief lecture about the syllabus overview of GATE, AA, and DS. Okay, and by the way, By the way, now we can proceed with on such an important topic uh, in data structures and algorithms. Okay, in data structures and algorithms topic, uh, programming in Python. So, and the next topic is nothing but basic data structures. That's nothing but stack. They have given the topic of stack, heaps, binary trees. The first foremost important topic is nothing but stack only. So let's proceed with the topic stack. Okay, so we can easily move upon with that topic. I hope it will be very useful. I think so. Once again, okay, let's move on with the topic. So data structures and algorithm is the chapter. Okay, so let's move upon. So let's see. This is an animation. Okay, this is a GIF format, GIF images format. Let's see how what's the difference within a fraction of a second that you can observe. The difference is nothing but the starting one book is there and ending also one book is there. So remaining books come and go. So some of the books got upon a stack of arrangement and another book goes down at the moment in a empty manner. So this is one such a flip flop or like a in pendulum, no? You can see it's a to and fro motion. By the way, here we can observe on such an interesting thing. So this is the way in data structures also happening. So that is known as stack method. Okay, that's known as stack method. The stack method is nothing but before going to see about stack method, we can arrive with the concept of data structure. The data structure is nothing but it's a method of the two most important word managing and arranging data. The management and arrangement of data in a certain manner that is known as data structure. So it helps us to maintain an efficient operation. That's the important process of a data structure. So what about the purpose? By the better management and arrangement of data in a manner, specific manner, the purpose is to provide a better storage as well as the organization. So that is known as database management systems, DBMS. So the data elements ought to be in better organization as well as in better storage. So this is the purpose of this data structure. Okay. So let's see here a pile of plates that have been arranged in a one above another in a stack manner. It's arranged in one below the other. So here nearly one, two, three, four, five, and six plates have been arranged one below the other. So let's see what are the terms that we have to know about this stack data structure. So stack is nothing but it's a data structure. In specific, it's a linear data structure that hold in an ordered sequence. The data elements are arranged in a ordered sequence. And it is a data type that in an abstract manner, and it's one such an abstract manner of a conceptual model which can define a data set on a operation and its behavior. The first foremost important process behind this stack manner is nothing but LIFO process, lost in first out. Okay, lost in first out means the element which was inserted at last will be removed first. For example, here let's see nearly six plates have been arranged. Here the topmost plate is arranged at the last time. So suppose if we need third plate, fourth plate or fifth plate, the first plate that we can take away is nothing but the last plate. So if we need to replace or if we need to plug any of the plates below the one plate below the other, first we took only the first plate. Okay, first plate is nothing but that is the plate that we have arranged in a last time. So that is known as lost in first out. Lost in first out means the element which was inserted last, the plate which was inserted last, the plate which was inserted last, okay, should be taken out first. That is known as lost in first out. So in similar manner, in a LIFO manner, the stack data structures will work upon. So let's see what are the operations and what are the parameters that have been involved in this stack data structure. Let's see in the following slides. So how to implement this stack? To implement a stack data structure, the sufficient condition is to maintain the pointer to stack top. Stack top. The top of the stack should be noted and to be maintained. And which element which was inserted at the last. So we need to know two elements of data. One is first and another one is last. That is the main thing in a stack data structure. What is the top of the stack? The top of the stack, like see here in picture, the top of the stack is the element, and this is the stack which we arranged at the last, because in first time we arranged this plate, second time this plate, third time this plate, fourth this plate, fifth this plate, and sixth time, last but not least, this was the plate that we have arranged at the last time. And one thing we need to note about, after arrangement of these plates, we can easily note that this is the first plate. This is the first plate and it was arranged at the last time. That is known as lost in first out. Okay, I hope you can easily understand what is the lost in first out process that was followed in stack manner. Okay. Okay, here you can easily observe what I have told in previous slides. Okay, so put a new plate on the top, remove the top plate. So lost in first out is nothing but put a new plate on the top. So this is known as put a new plate on the top. Lost in first out means remove the top plate. This is known as lost in, and this is known as first out. LIFO process, lost in first out. Put a new plate on the top and remove the top plate. That is known as LIFO process. So if we want the bottom plate, if we need a bottom plate, I need 1 2 3 4 5 6, I need a sixth plate. I want to first take out this first plate, second, third, fourth, fifth, and then only I can reach the sixth plate. Okay, I hope you can easily understand. So this is a thing we need to observe. What is the LIFO process? I hope you can easily understand. If I need a third plate, or even if I need a second plate, I want to remove the first plate. I want to remove the first plate only means I can easily take out the second plate. So this is known as lost in first row. So the lost plate that I was arranged is nothing but the plate which was placed at the top of a stack. That is known as lost in first row. Okay. So this is exactly the stack data structure works. Okay. Fine. Let's see a theoretical concept. Let's see coming into the logical concepts. So the push and pop, these are the two words, technical operations that we can used in the stack data structures, that is arranged in a stack data structures. Push is nothing but arrangement, addition of data elements in the stack. So it can build upon, build upon, build upon. It will give you a stack, pile of stacks. So the push operation only helps to helps in the addition of data elements to form a stack, to form a pile of stack. The pop is nothing but the removal of the data element. The pop is nothing but the removal of data element. Keep it in mind. Push is nothing but addition of data element. Pop is nothing but removing of data element. This is known as important process in data structures of stack. So let's see the data element was in, that is known as push. Data element, data element, data element, it will get like a step upstairs manner, and pop will do alternatively. Consequently, the pop will do opposite to push. Pop and push are opposite to each other. It will easily took out the data element from the stack. That is known as the pop. Okay. Okay, by the way, let's see an important illustration. This will help you to understand whatever that I have taught in previous three slides. Okay, let's see the push and pop operation in stack. So how this uh, process has been done? Let's see. Here there is an empty stack. Okay, here there is an empty stack. If I want to insert if I want to insert the data element 5, okay, it's an integer data type. So if I want to insert a data element 5, so I can push the data element 5 into this stack. So again, over 5, I can push another data element 6. So it is push 6. So this is a pile. Okay, this is not a stack, and after pushing 6, it form a stack. That is known as important. So this is an empty stack. This is a single element. This is not a stack. Now it is a stack because it forms a pile. Okay, more than one data element occurs in the, so it form a pile. Okay, so empty stack, single element, it form a stack. So upon this, I want to take a data element from this stack, this push 6 stack. I want to take a data element. So now I need to apply a operation known as pop. Pop 6 means it will easily comes out. So again, the initial stage of push 5 is there. The pop 6 compared to this illustration, the pop 6 is equivalent to the push 5. Okay, the pop 6 is equivalent to push 5. So we can easily observe the difference. So because here I can pop the element data element 6 from this stack, and next to, if I pop the element remaining one element 5, it will come out. So this pop 5 is equivalent to this empty stack. So I hope you understand what is the push and pop operation in stack data structures. Okay. Next, so let's see an analysis. How technically the top, I mean this push and pop works. Okay, let's see. Here there is a technical arrangement. Okay, technical arrangement. How this works technically. Okay, let's see. Empty stack. So initial stage we need to be consider the top means it's one such an operation that is used in a stack data structures. We will see in next slide what is depth in we can see in depth what is the term top in this stack data structures. Top is equal to -1 because here there is an empty stack. So the top is equal to -1 denotes there is no such a data element present in a stack. So in the initial stage, that is in specifically I can say in an empty stack, the stage which occurs in an empty stack, there is no such a data element. There is no such a, even a single data element. It is known as empty stack. Okay. In that stage, the top is equal to -1. So it is an indicator. It's an indicator there is no such a data element. Okay. Next, if I push a data element, integer data type element 1, here the top is becomes 0. Again, if I push another data element 2, the top is equal to 1. Again, if I push another data element 3, the top will become 2. So if I pop a data element, the 3 from the data stack, from the stack of a data, it will goes to again 1. I hope you can easily understand what is known as a top. The top is nothing but an indicator. Okay. So the top denotes, okay, the top denotes how much element that is added. So it is nothing but a n minus 1. It's similarly in mathematically we can array the top which is equal to n minus 1. I hope you can easily understand. So by the way, here see, let's see an analysis. If top is 0, the stack 0 which is equal to 1. The stack is nothing but how much data element in a stack contains. That is known as stack is equal to 1. Again, this is known as a stack is equal to 1 means here there is no such a, here it denotes there is one data element. Again, stack 1. Stack 1 means here it is 2. Okay. Stack 1 means here it is 2. Again, stack 2 is nothing but 3. How much element that is it occurs here. And return stack means whenever the stack get written, there is a pop arises. There is a pop arises. That okay. I hope you can easily understand what is a top, what is a stack, what is a return stack, and what is an empty stack, push and pop. Okay, fine. So let's see. Uh, Another one such an important operation of stack data structure is nothing but peak. Peak is nothing but we need to pop. It's one kind of pop only. It's one kind of pop. We need to took a top of a stack. It is to took out a top of the stack is nothing but peak. Okay, so here there is a pile of books that is arranged. This is a real life stack. If I want to suddenly took out the top orange color book alone, if I want to took the top orange color book alone means the operation data operation nothing but peak is applied there. Okay, so push is nothing but addition of data elements, pop is nothing but removal of data elements, peak is one kind of pop. It's similar to pop, but pop can remove all sorting of arrangements, but peak data structure only removes the top of the stack. Okay, I hope you can easily understand. Next, let's see a stack of data structure. Here it is arranged. All four red color stack is arranged. Push is nothing but just addition. Pop is nothing but just removal. Peak is nothing but just took out the top of the stack. Okay. Okay. Next, some other operations in accordance in addition with push, pop, and peak. There are two operations. One is empty and another one is full. Okay. One is empty and another one is full. Let's see what are there. The basic operation of stack. There are some basic operations to perform, different operations in a stack. Push, pop, is empty, is full, peak. Okay. So I go, um, I already demonstrate the three basic operations: push, pop, and peak. Push is nothing but addition of element. Pop is nothing but removal of element from the top of the stack. Peak is nothing but get the value of the top element without removing it. Okay, fine. Sorry, in accordance with I have misunderstood that. Let's recreate not such an important concept. Peak is nothing but to get the value of the top of the stack. Peak is nothing but an operation to get the value in the top of the stack. What's the element, data element value occurred in the top of the stack without removing it. Okay, without removing it. I make a sorry. Push is nothing but addition of data element. Pop is nothing but removal of data element. Pop is nothing but removal of lost data element. Okay, lost data element. Sorry, in accordance, there is a little bit of confusion occurs there. So please make a excuse. Okay, push is nothing but addition of data elements in a stack, which will make a large stack. Pop is nothing but we need to remove a top of a element. So at that condition, pop is used. The peak is nothing but we need to know the top stack element value. We can usually use the operation peak. Okay. So by the way, um, the another two important operations nothing but is empty is stack. Okay, let's say about is empty. Is empty is nothing but to check this stack is empty or not. Is full is nothing but to check this stack is full or not. So one is contradict, both are contradiction to each other. Let's see. So how this stack data structure works. Here a pointer top. Pointer is the top is nothing but a pointer. It's a tracking agent. Okay, it's a tracking agent used to track how much element are present in the top of a stack. While initializing with this pointer, we need to set its value is equal to -1. So top which is equal to -1. On pushing an element, on pushing an element something but by pushing operation, we can easily push a element, data element into a stack. The top value get increased by 1. Get increased, yeah, it will keep upon increasing. By popping an element, it reduces its value because popping is nothing but removal. Okay, before pushing we check if the stack was already full or not before pushing, because if the stack was full there is no possibility of pushing a data element because there is no such a space occurs there. So before pushing, they use an operation is full operation, whether the stack is full or not. Before popping, we need to check if the stack is already empty or not. So if the stack was empty, there is no such usage. So before the stack was empty, we don't need to pop the element from the data structures. Okay. So this is also an important concepts of push, pop, and peak. Okay. So again, once again, the slide that I have taught you in the previous slides, I can demonstrate you once again in accordance with this working principle of stack data structure. So here the top is equal to minus 1 in accordance with the first rule. Second rule, we are in initializing stage. So there is no such an empty stack. There is no such a data element. So it results in an empty stack. Again, in second case, we push a data element 1 into the stack. So here the top increases to 1, 0. Again, if I push another data element 2 in the stack, so it again moves to top 1. If I push another data element 3 in a stack, the top moves to 2. So by the way, I pop a element 3 from a data stack, it again decreases to a value 1. So this is a several operations, a beautiful operations occurred in a stack data structure. Okay, I hope. So let's see. Here there is a stack implementation in Python, C, and also online C compiler. Okay, let's see what are the important. Let's see. Let's recreate a code in a online Python compiler. Okay, uh, let's see how does it works. Okay, so this is also an important topic uh, that I took from programmist.com. So let's run this code. Okay, so first of all, before running a code, we need to analyze what are the things that we are going to see about this code. Okay, so here we are going to creating a stack. Okay, so to define create stack which is equal to first time is empty. So if a stack was empty, we can easily return a stack. So creating an empty stack. Okay, creating an empty stack. So check empty stack, return the length of the stack is 0. So adding our items into a stack. So push. So that's the case that I have taught you before. Push is nothing but important operation stack. So we are going to adding an element into the stack. Push stack item, stack dot append item, print pushed item, that is plus item, removing any element from a stack. So define pop stack. If check empty stack, return stacks empty. So return stack dot pop. Again, stack is equal to create underscore stack, push stack string 1, string 2, string 3, string 4, print popped item plus pop stack, print stack after a popping any element, string stack. Okay, let's see, run this code, how does it occurs in a Python. Okay, the pushed item is 1, 2, because it's a string. Okay, 1, 2, 3, 4, again 4, because here the pushed item is 1, push item is 2, 3, push item is 4. Here the last element is 4 and the popping item is also 4. Like this, like this one. Okay, here 1, 2, 3. Here the pushed element is 1, pushed element is 2, and pushed element is 3. Again here the popping element is also 3. In case, that's the important case that we have seen here also. The pushed element is 1, 2, 3, 4. Again, the popped element is also 4. Okay. So stack after popping an element. So we doesn't include the pop item. So we just include only the item before popped. Okay. So here only the elements are included is nothing but 1, 2, and 3 in a list manner. Okay. Let's see how this works in a C programming. How this works in a C programming. So let's see how it's the same type of the same methodology of coding is followed here. Let's see how does it happens. Stack implementation in Python. Okay, stack implementation in Python. No, it's not a stack implementation in Python. It's stack implementation is C. Okay, let's see. Creating a stack, define create stack, return stack. Okay, so here define a stack, stack is equal to empty, return stack. The same code is followed here. Let's see how does it happen. So here there is an error occurs. One second. Okay, fine. Let's see how does it runs here. Here there is include standard input output value, standard library. Here the maximum 10 is defined. So let's see how does it works. Here the integer count here is equal to 0. Structure stack, integer items maximum, integer to the top. Type define structure, stack st, and also void create empty stack, etc. etc. Int is full stack into s, and also if s to the top maximum minus 1, that is known as is full. Return 1 else return 0, again int s empty, and also stack into s, return 1 else return 0 void. So these are one such an important codes that we have performed in stack. Okay, so let's run this. So we can obtain stack 1 2 3 4, item popped is 4. After popping out 1 2 3 is present here. Okay, let's see in C++ how does it works. Okay, in C++ how does it works. Let's see. I think it got an error. So by the way, I hope you can easily understand. In GATE syllabus, they have asked only for Python only. So by the way, whatever may be the programming language, whether it's a Python, Java, or C or C++, C hash, it's not an important matter. But how this stack operation works is an important matter. Okay, I hope you can easily understand this topic. So again, once again, I can easily go through a glance over this topic. Let's see. Today we have started with the data structures and algorithms for gate examination for EA and DS, artificial intelligence and data science. So the first topic is nothing but how this animation works. This is an important curiosity behind this topic. And the first topic is the first definition is nothing but about data structure. What's the purpose? Next is nothing but what is a stack and what are the process, LIFO process is being there. The main ultimate aim of the stack data structure is nothing but LIFO process only. How does the LIFO process works? That's the thing that we have seen. And what is the two major fundamental operations behind this stack data structure? One is push and another one is pop. Last but not least, we can easily see with another one such an important operation, peak. Peak is nothing but to get a read value of top of a stack without removing, without popping a top of the stack. We can easily read the value by using the peak operation. And in addition to these three, push, pop, and peak, where there is two another important operations thing, but is empty and also is full. Okay, so push is nothing but adding an element, pop is nothing but removing an element, peak is nothing but remove without removing. We can read the top element value of the data element. Is empty is nothing but to check whether the stack is empty. Is full is nothing but to check the stack is full or not. Okay, here the pointer top is present before initializing. At the initializing stage, the top value is set to -1, and by pushing an element, the top value get increases. I mean, the pointer value get increases. At the final stage, we doesn't include the point. We doesn't include the popped element we only input before the popped element only. So this is original stack manner. This is also important stack implementation Python. So I hope in Java also that is. So guys, let's see in another important topic in second lecture of stack, and I hope you can easily catch up with my English lecture. Okay, in accordance with, I can also move with Tamil because I want to be teaching both English as well as in Tamil language. So this is a nice platform to be in friendly manner to learn. Okay, so let's see, and please spread this video, this channel, Coder Joy channel, to all your friends and makas. Okay, all your friends. Okay, all your relatives, whoever enthusiastically and meticulously preparing for a gate examination. Okay, let's see in another important class. Thank you. Bye bye.